These topics of presentation is pixel-based assessment of future trend and directional distribution of precipitation in the Kush Himalaya region under the changing climate condition. Now, the floor is your side.
So good morning and assalamu alaikum and suprabhat namaste and thanks everyone. First of all, I really thanks to ICI mode what we have to do on the presentation. I have attended lots of conference, so very few conferences have such a things what you are talking about and you are implying on the ground. So for example, ICI mode had the capacity to build this ID card in plastic form, but they use a eco-friendly product. They can use the water bottles and what we are taking, so they use the simple glass bottles, not using the plastic. So I really appreciate that things. So before starting my presentation, I am Mohammad Saidul Hassan and as an early career researcher. So my the research topic is basically pixel based assessment of future trend and directional distribution precipitation in the Hindu Kush Himalayan region. The important because most of the colleagues here are from different background. So before taking the topic, just I have to clarify the things. Why we have to take the pixel? Because the things are distributed in a grid format, and when a satellite is taking the picture of the earth, it is just simple like taking the selfie of the earth. Just we are taking the mobile pictures now. So in the same way, so each and everything is distributed in a uniform grid, that is a 0.25 by 0.25 degree grid formation. Okay, pixel size. And the thing is that we have used the data Persian CDR, that is the precipitation estimation from remote sensing neural based on the artificial neural network, and it is developed by University of California. So the thing is that why this study is important. If we talk, most of the rivers in Southeast Asia basically dependent upon the Himalayan precipitation, because these rivers are basically perennial rivers. So if we talk about Pakistan, the Indus River act as a lifeline. In the same way, in India, Ganga Basin is acting as a lifeline. And in the same way, if we talk about the Tibet and Bangladesh, Brahmaputra plays a crucial role. So if we, in another perspective, if we look, so most of the global population also reside here. Means the Indo-Gangetic plain having the world's densest aquifer system based on the population distribution. So what we have observed in this research, we have taken, means whole study area have around 6,000 something, 6,100 something pixels covered over the area. Out of which 4,000 pixels are showing there is some increasing trend. The interesting part is that you have where the increase in precipitation taking place and where it is decreasing. So 2/3 of the pixel or 2/3 of the Hindu Kush Himalayan region showing the average increasing trend of the precipitation, but 1/3 of the which is located in the Southeast Asian region. If you talk about the Nepal and may I see slide?
Sorry, can you speak just a bit further? Because I can hear better.
Okay, sorry. From the study area, you can see how the extent is. So that's why the geopolitical issues also are. From the picture, we can easily understand how the geopolitics is governing the Hindu Kush Himalayan region. So the main is.
Sorry, speak a little bit Can you use this one?
Sure. Sorry.
Much nicer.
If we see, the interesting thing is here, please look it at LPA, that is the long precipitation average. it's an annual basis. We have done the analysis on the annual basis. So from 1986 to 2020, around more than 30 years, we have taken the data set, and this one long period average precipitation on the annual precipitation. If we see in this figure, the average mean precipitation over the Hindu Kush Himalayan region, means these regions, the Indo-Gangetic Plain as well as the Myanmar, Bangladesh, these regions, Leh, Ladakh, having the maximum precipitation. Mean precipitation is maximum, but in the upper part of the Himalayan Kush region, or in what you say, these regions of Pakistan, Afghanistan, having the minimum average precipitation over more than 35 years, 35 years of average time period. So, but when we do the non-parametric test, that is the pixel based analysis, and you can say it's as a multi-point statistics also. So from here, if you see the same slope, so before why we take the non-parametric test, because when we deal normally while taking out slope, the data set must be in our normal distribution must follow, but from the most of the research it shows that climate data do not follow any normal distribution. So the beauty of this test is that it will consider the effect of outliers also. Okay, so there is a more robust technique to calculate the trend of any climatic parameter. So if we see, and the p value is the significant level. So if p less than 0.01, that is at a 99% significance level, and p is less than 0.05, that is 95%, and greater than 0.05, that is the insignificant unit. So if we look into that, the green p value, the polygon points are basically showing that the 99% significant our data set. So these are basically in the upper regions, okay, mostly. But if we look the future trend of precipitation, that is the red. If we look from the legend side, the minus 32 millimeter per year of declining trend of precipitation is taking place. These regions. So what we do and what we look and what are the consequences of this declining trend? If you go the consequences, what happen? Basically, the rivers which are flowing from these parts, they are basically the perennial river. And now, during the monsoon, the more study shows that there is a shifting patterns of monsoon season taking place. Means the monsoon precipitation shifted to pre-monsoon season, means summer monsoon precipitation is increases yearly basis. Now the thing is that the effect is taking place as a groundwater, means the depletion of the groundwater. That's why the Global Climate Organization system consider groundwater as an essential climate variable, just as a precipitation, temperature, and or humidity, wind speed, and other parameters. So why the exploitation are taking place, and that exploitation also leads to many research from the nature and good journals also shows in the region, means Bangladesh and India, in West Bengal, most of the regions are basically having the toxicity in their groundwater, and that toxicity basically caused due to the geogenic process and the over exploitation of the groundwater also, and which indirectly or directly also affect the agricultural productivity of that region. So the food security is also a great concern to that region also. Now the thing is that most of the regions of upper Hindu Kush Himalayan regions are showing the increasing trend of the precipitation, that is around 13.5 millimeter per year. So the another thing is that these regions also having more and more chances of increase in flooding. So if we see from the increasing trend, so these regions are also, means the consequences of flood is also nowadays happening in Pakistan and upper regions. Okay, so overall, if we see that this is the directional distribution, one standard ellipsoidal ellipse. So what we see the green circle, green ellipsoid, showing that is the most of the positive trend is happening in these regions. Okay, and the red one ellipsoid showing that is the most of the declining trend of precipitation is happening in this region. Means the consequences and the frequency of the extreme events like drought is taking place in that region is more prominent. Okay. Now the important thing is that if we look this picture, okay, the psychology of humans say, okay, this is the maximum mean precipitation over 35 years. So women or the local people say no, that is the okay, precipitation is happening. But when you do this type of analysis using non-parametric test, now you can see how the precipitation is behaving like. Means these regions having the total declining of around, that is around minus 94 to 6, means you can take around 94 percentage decrease in the precipitation over these regions, that red region, okay, over the period, and that decrease is going to take place in future also. Now the important thing is there, so you can see that these regions are having high percentage of a change in precipitation, that is a positive change. These regions are also having the positive change, that is around, you can see here, maximum of 134, okay, 134%. Now these things are basically disturb the eco-hydrological process of the system or of the region. Now the thing is that why this, as many speakers already told, and that's why the nature-based solution comes into the picture. So now right now, so after all the overall, the thing is that okay, these studies are really helpful to achieve the United Nations Sustainable Development Goal, whether it is the SDG 1, 2, 3 and 6 or 13, 14, and all the more or less all the, and ultimately I thanks to ICI and what, because he is they are working to achieve at SDG, that is the 17, to make a collaboration among the different peoples from the different organization and the different parts of the world. And so I'm thanks, and if anyone have any questions, so please have, and I'm really appreciate those who want to work with me in future collaboration. I really happy to collaborate with them. Thank you.
Thank you, sir. Thank you very much. Very technical presentation. Maybe now floor is open. Yeah.
Yeah, thank you for your presentation. I just want to know some simple query, like which data you use.
Basically, there are lots of data for the precipitation available on the Google, or you can say different organizations like NASA and other organizations are providing. For this, I have used Persian CDR. That is the one of the what you say, in collaboration with University of California and NASA. Yeah.
Okay, and as we compare the first picture and the fourth picture, we can see very contradictory result. I mean,
this one is
yeah, this one, because as you said, like the first one, rainfall is increasing in the foothills, the downside of the HKH region.
Yes, that is the mean precipitation over the 35 years.
35 years.
Yes.
And as we see in the last picture,
yes,
and it is drastically decreasing.
Yes.
It's a future value or it's a present value?
It's using the precipitation of past, we can predict, because the slope is giving the direction and the magnitude of the trend at what level it is increasing or decreasing. So from here, there is just a simple equation of percentage change. We have used the slope multiplied by the length of the time series into 100 divided by the absolute mean of the over the 35 years of the time period.
Okay.
Thank you, sir.
So are the areas in the green and the red both at increased risk for drought and for flooding? Is this seasonal disparities increasing the risk at both ends?
Means you are asking regarding the flood and drought conditions. Okay. So first and foremost things I will tell you. Right now we are not heading towards climate change. We are in climate crisis. Okay. These things we need to understand. Now what happens if the precipitation is increasing and the data set we have used, it's a annual. That's why in general the perspective and the most of the precipitation takes place in monsoon season in India or in Indo-Gangetic plain or in part of the Hindu-Kush Himalaya. But now that trend is shifting to pre-monsoon, means the shifting pattern is also taking place. That's why there is one professor, Dr. JK in IIT Kharagpur. He has done one of the research and published in environmental letters that the magnitude of the trend of the precipitation that is located in Chirapunji, that is the highest means over the earth, the maximum rain taking place, it is also showing the declining trend of the precipitation. That is the one of the most challenging issues. So if we take into the pictures, so those areas which is showing the less precipitation is the consequences of drought will be more, and the area which is having the more precipitation increasing as the days increasing or year increases, there is a consequence of flood also. And another student, because the problem, it's not a problem, we are in developing phase, so there is a one satellite called the GRACE, Gravity Recovery and Anomaly Climate Experiment. So from that work and from that papers, it is also seen that most of the groundwater means terrestrial water storage, because in GRACE what they do, they measure the canopy water, surface water from river, lake, even soil moisture and groundwater storage, because the mass variability is basically taking place due to the how much amount of the water flow from one place to another place. So the research from the Rodel NASA, the author Rodel and using the GRACE data, they also predicted that the Indo-Gangetic plain having the more water scarcity and more vulnerable to the groundwater resource, and which directly or indirectly affect the socio-economic condition of that region.
Any other question?
Thank you for your presentation. My question to you is that you talked about increasing and decreasing trends in
Yes.
the study area. So
Yes.
did you perform Mann-Kendall non-parametric test
Yes,
for that?
Mann-Kendall, non-parametric and based on the sense law, because we have the time constraint of 10 minutes, so we have
Okay.
reduced
So,
our
and how
research.
significant those trends were? Like what p-value?
Most of the here see actually from my there is issue with my slide. I am sorry for this. So p is less than 0.01. The bracket mein there is a number of polygons 51, and that is the you can say pixel in that polygon show at 99% significant. And if we are the red polygon showing the 95 significant, that is the 188, and non-significant, that is around 60 polygon showing the non-significant.
Thank you.
Okay, thank you.
So, if there are no more questions, let us thanks to Syed for his very technical presentation.